Hello everybody, so for those who find my video without going through my website, let me introduce myself. My name is Gilles Lauzon-Urtubise, and my name as a self-taught and multidisciplinary scientist and inventor name is Gilles Lauzon-Urtubise, and I am the owner and the founder of the first human multi-intelligence.com site. So I think so the title of this video, and I think, is again how our galaxy, the Milky Way, was born and how it has evolved so far. And this is the part 15, which followed the part 14, and I think it's the last one of this series of video. And this video is the continuation part, of course, of the part 14, and the continuation in the text, which is in the article, which the name is the Black Hole 44. So, and the continuation is with this paragraph, which the number is 17.22.8 point. By hypothesis, what is the mass of our supermassive black celestial sphere and the rest of our Milky Way galaxy just after their birth? And they must be close to one of the following possible set of masses. So 17.22.8.1. In one case, for example, the mass of our supermassive black celestial sphere daughter in the center of the Milky Way is between 150 and 200 billion solar masses. So, but these range of masses is too low for me. Concerning then the age of our galaxy is pretty young, and it's somewhere between 6 and 20 million years old. So I think then the mass of which is only between 150 and 200 billion solar mass, is too low, and for the mass, which is 40 billion less for the rest of the object, and which is between 110 and 160 billion solar mass for the rest of the objects of the Milky Way, just at the moment of their birth. In the next case, is it possible that the solar and the mass of our supermassive black celestial sphere daughter could be between 250 and 300 billion solar masses right after his birth? I'm not sure, because I think this this range of masses is quite low. So, well, maybe, but we'll see. And a mass for the rest of the objects should be between 210 and 260 billion solar masses. So I think this mass is quite low too, because this our galaxy is a pretty young galaxy, which its age is between 6 and 20 billion years. So what about the next case? Is it possible that the mass of our supermassive black celestial sphere daughter of the center of the galaxy, which is between 350 and 400 billion solar masses? I think it's absolutely possible if the age of our galaxy is around 20 billion years. So, and for the mass of the rest of the objects, it could be somewhere between 310 and 360 billion solar masses. So, and what about the other case, which is our mass could be between for the our supermassive black celestial sphere daughter, it could be between 450 and 500 billion solar masses. I think it's possible if the age of our universe it's only around 6 billion years, and its mass it's between 410 and 460 billion solar masses for the rest of the objects. So the next paragraph, 17.22.8.5 point, in conclusion, those which seem to be closest to a possible reality and those which varies between 350 and 400 billion solar masses, if the age of our galaxy is around 6 billion years, and for the rest of these objects it's between 310 and 360 billion years old. If its age is if its age is around 20 billion years. So if it's around 20 billion years, its age it could be for the mass of our supermassive black celestial sphere daughter, it could be between 350 and 400 billion years at its birth, if the age is 20 billion years for the galaxy, the Milky Way. But if its age is between 450 and 500 billion years for our supermassive black celestial sphere at its birth, so at that time the age of our galaxy it should be lower, and it should be around 6 billion years. And for the rest of the mass of the objects of our galaxy, it should be between 410 and 460 billion solar mass, if the age of our galaxy is around 16 billion years. So next paragraph. Currently, next paragraph is 17.22.9 point. How many satellite galaxies are there shortly after the birth of our galaxy, the Milky Way, and our supermassive black celestial sphere daughter from its center to be captured by the latter? The answer to this question is relatively simple and logical, based on the following reason. So paragraph 17.22.9.1 point. Currently, our galaxy, black celestial sphere daughter in the center of the Milky Way, is capable of carrying with it all of its objects its 56 satellite galaxies and their objects it moves in its gravitational captures orbit around a supermassive black celestial sphere, which is even more massive, and which is that of the one at the center of the great attractor, or which is the great attractor. So next paragraph, 17.22.9.2. Accordingly, if our supermassive black celestial sphere from the center of our galaxy is able to pull, so the one which is the daughter one, is able to pull with it all of its objects in its gravitational captures orbit. This is because it was gravitationally strong enough to capture the supermassive black celestial sphere daughter from the center of the... I repeat this phrase again. This is because it was gravitationally strong enough to capture the supermassive black celestial sphere from the center of the 56 satellite galaxy. and all of which are smaller and less powerful than it. Next paragraph, 17.22.9.3 point. In this context, it is possible that it captures the 56 satellite galaxy just after its birth. Or, paragraph 17.22.9.4, in another context, it is possible that it captures between 53 and 55 satellite galaxy just after its birth, and thereafter that between 6 and 20 million that between 6 and 20 billion years of life, that it captures between 1 to 3 additional satellite galaxy for a total of 56, which she have right now. Next paragraph, 17.22.10 point. By hypothesis, what are the reasons why our galaxy, the Milky Way, has 4 dominant spiral arms in the spiral shape with such a quantity and concentration of objects? So the possible answer may be one of the following. 17.22.10.1 point. Because its bursts come from a violent surface burst and then a large supernova explosion between 2 supermassive black celestial spheres, and which the biggest one is a part of the 5th, 6th, or 7th class of those which are the most voluminous in the universe, considering that the Milky Way is the second largest galaxy in the local group. And 17, next paragraph, 17.22.10.2, because this violent burst on the surface and then into a large supernova explosion, it served to birth our supermassive black celestial sphere daughter from the center of the Milky Way, who is part of the 5th, 6th, or 7th class of those who are the most massive and powerful in the universe, because by producing 4 imposing and slender arms of 100,000 light years long, and among these a certain amount of black celestial spheres which are relatively small and which I found following their birth to capture all the objects which are nearest, so as to increase their number and concentration in reach to their imposing and slender arm of 100,000 light years in length. So that's enough for the video, and welcome to the next.